In this video, we will have a deep look for bundle, and we will see that it is not enough to know the base and the fiber in order to know how to construct the bundle. Some bundles have many ways to construct them using the same base and the same fiber. A very famous example is Mobius band. A band, if you have a band, there is at least two way to construct, which is they have the same base and the same fiber. Let's say the tangent field is as a fiber, but still you can twist it, and you cannot twist it, or maybe you can twist it twice and three and so on. So here we take a very simple case where it's just one twist. So in the first A and A bay and A prim and B prim is connected, but in the second case the opposite happen. That means when I make this, there is twist. In both cases, the locally are exactly the same. So if you have a very small observer walking on the band, he will not notice any difference. But for the global overview, it's clearly they are not the same. So how we can deal with this case, with such cases? Of course, we need to find a new way to define the bundle in a more precise way. And here we will see that this more precise way require us to use a group structure, and also we need to introduce homomorphism. This way is called bundles group structure. To have a look about this new concept, we need to define the homomorphism, which is one-to-one map, continuous, and has an inverse, and also its inverse is continuous. So one-to-one map, continuous, has a continuous inverse. So this is the homomorphism. In the new concept, or the new way to construct or define the bundles, which is called bundles group structure, require the following ingredient. You need base, of course, and you need projection, which connect each element of the fiber with an element with the base, and of course it is one-to-one map and continuous and has an inverse, and its inverse is continuous, so it's homomorphism. And you need a typical fiber, let's call it F, for example tangent fiber, or any fiber you wish. Fourth, you need structure group of homomorphism of F onto itself. And this structure group of homomorphism play crucial role in this redefinition. Of course, finally, you need family of open set UI, such that the union of this family of open set will cover all the base, and this is the ingredient. But it is not enough. Now we need to make some condition, or a way to prepare a bundle structure group depend using these ingredients. The first condition, the bundle over any open set UI, which is just B-1 UI, has a homomorphism onto UIF. UIF is space product, which is ordered pair of element. The first is from UI, which is open set of the base, and the second is an element of F, which is a member or of the fibers of the fiber. So this homomorphism, let's call it HIX. X is an element of F, and I indicate the indices of the open set we take. So each open set there is such kind of homomorphism. The second, let's suppose we know previously that this open set, which cover all the base, must intersect must have intersection area. That means we could find X in the intersection area between two neighboring open set, UI and UJ. In these cases, of course, we have two homomorphism, HI and HJ, and these two homomorphism onto F. And since they are homomorphism, so they are invertible. So we can find HJ minus 1. So we can make composition HI composite with HJ minus 1, and this is defined over F, and the arrival is also F. So there is two element, an element of F with a connected this kind of homomorphism, connected number or a member of the fiber with another member of the fiber. So this is the general structure. Now, how we can use this ingredient with these conditions in order to solve the problem of the global overview in Mobius band? Every open set, we know that every open set have coordinate system locally is Euclidean, and there is coordinate system locally around each element of this. And we previously say, let's call this coordinate lambda e. We just use lambda e in order to make it obvious, because we already use x as a member of UI. So we use other letters to represent the coordinate system. So now, if we take, for example, in the bundle structure of Mobius, bundle structure group of Mobius band, let's take fiber as tangent space. Then the projection will connect each pair of x, v with x. So x is a member of an element of the open set, v is a vector of the tangent space. Since it is a vector of tangent space and a member of tangent space, it could be written as the sum alpha I d over d lambda I. And here we use Einstein convention, that means there is sum. So we have E coefficient, and d over d lambda I is the base of the tangent space, as we see previously. Now let's take an element of the intersection area of two neighboring open set. Then there is two homomorphism HE, HJ. Each of them, HE connected a vector with the coefficient which are used to represent this vector. And also there is another homomorphism, connected the same vector with with other coefficient, because we have this element is in the intersection area. Now since it's homomorphism, we can take the inverse, and we choose a suitable composition between HE and HJ, and we will get a map at alpha E with alpha G. And it's clear, and this homomorphism from R1 to R1, because this coefficient is a real number and non-vanishing, non-zero. Since they are non-zero, we can take the ratio between them. Let's call it REG, which is alpha E over alpha G. For simplicity, we can take alpha E amplitude equal alpha G amplitude. And in this way, REG will be either +1 or -1. R1, if we exclude 0, it is a group structure under multiplication. For more general, for n-dimensional manifold, the structure group of the fiber, the bundle, the structure group of the bundle, Fm, and here, since we use F fiber as a tangent space, we can call it Tm, is n multiplied by n matrix. How we could use this new way of construction or definition of bundles in order to solve Mobius band is the following. Let's suppose I represent a bundle, a twisted bundle, one time twisted bundle, with, for simplicity, with this circle, and we take 8 open set that they are overlapping in order to cover all the band. Now we choose HE, the composition law HE HG minus 1, which connecting the two real coefficient alpha E with alpha G in the following way. REG equal 1 except when R8 1 we choose it -1. That means when we want to connect the two end of the band, we inverse it. This structure group have two elements, just 1 and -1. And under multiplication law, it's a group, as we see, and this is a way to recognize the two global overview, the two global of the bundle, using the same base and the same tangent vector, the same fiber, but using a group structure, we can now recognize which kind of fiber bundle finally we have. For example, if we take all the coefficient or all the real ratio number REG equal 1, including R81 equal 1 instead of -1, we will get the untwisted band. And in this way we we have we solve the problem of the global overview of the bundle.